Hello everyone, and welcome to the section 5 of the Artificial Intelligence in 3 hours. In this section we are going to talk about the most promising area of the artificial intelligence, reinforcement learning. In this video we are going to explore what reinforcement learning actually is. So far we had talked about supervised machine learning or unsupervised machine learning. But in reinforcement learning we are trying to build something that will think and act on its own without any human interaction. You can see an example of applying reinforcement learning in a real world, which is in this case vacuum cleaner. It is going to go around the house, try to find dust on its own and clean it. Another example of applying reinforcement learning is AlphaGo. A few years ago DeepMind, which is most advanced research group out there, had made an algorithm called AlphaGo, which back then had beaten the best player of AlphaGo in the world. So in this image right here you can see that it applied or found a move that nobody understood except the algorithm itself, and made a move that Lee Sedol didn't predict at all. We can apply and solve very complex problems just by using reinforcement learning. Let's take a minute to talk about the environment that we are going to use in this section. As you can see, it is very simple, but concepts and techniques that we can apply here are also applicable to any other problem. Because reinforcement learning is so vast area, this section is going to be like a light introduction to it. This is our environment, and it is called CarPol V1. The goal of this environment is to use the small platform that moves right and left to balance the stick as long as possible. For each time step, our agent will receive 1 as a reward. If the platform moves too far from the center, it is going to lose, or if the stick is more than 15 degrees from the vertical, the agent loses. The goal for our agent is to learn how to move the platform left or right, and how much to move it in that direction. Playing games is just one environment that we can use to train our algorithms. But there are many more approaches and problems that we can solve using these algorithms. Resource management, traffic control, robotics, and many more. They are very important because they are so complex that we cannot just apply, for example, supervised machine learning to solve traffic control, but we can use an algorithm that is going to learn on its own to solve this problem. And that's it for this video.